Today, let's discuss a problem about 6 friends. Of course, it's not the TV series Friends. It's such a problem that if we choose any 6 people around the world, any 6 people, for example, we could find 6 people on the road. We could even pick any 6 people on the internet. There is such a phenomenon that among these 6 people, there must be 3 who know each other or 3 people who are totally strangers. This conclusion looks strange. If you feel that it is impossible, you could do some experiments. This is actually a situation of the Ramsey problem. Mentioning Ramsey, he was very famous because he was born to the purple and he was a philosopher, mathematician, and economist. He is a member of the King College, Cambridge, and also a famous scholar. He raised a logic analysis method about decisions in economics. So many think that his contribution to economics is way larger than his contribution to mathematics. However, he saw that his interests are on philosophy and mathematical logics. Unluckily, if we look at his date of birth and death, we'd find that he died in the year of 26. It said that his early death is a great loss for economics and mathematics. Now let's look at what exactly the Ramsey problem. Actually, Ramsey problem is still on the frontier of academic research. Some American combinatorics even said that if you ask them what's the most beautiful part in combinatorics, most mathematicians would answer Ramsey problem. The former president of American Mathematical Society once used Ramsey as his car number. There exist around 2,000 to 300,000 academic papers discussing Ramsey problems. And how many Ramsey numbers could be computed by us? So far, we only know value of 10 Ramsey numbers. All other Ramsey numbers are still unknown. What a hard problem it is to be so fascinating. We just said that among 6 people, there must be 3 mutual friends or mutual strangers. So we could convert the problems to a coloring problem of the complete graphs. The relationship among 6 people could be represented by complete graph K6. What's the K6? Let's look at this graph. With 6 vertices, if all possible edges are used, it's the complete graph K6. Similarly, for 3 vertices, it's a triangle. For graphs with 4, it's just a cross graph. We could also find the complete graphs with 5 or 6 vertices. The coloring problem of complete graphs is that for complete graph Kn, if we color all its edges with 2 colors, there must be a complete subgraph K something colored with a single color. Take 6 vertices as an example. In a complete graph K6, there must be some mutual friends or mutual strangers. Let's model it with a 2 coloring. Suppose with a color with red and blue. A red edge represents that 2 know each other. A blue edge means that they are strangers. A Ramsey problem means that for a complete graph with 6 vertices, if we are performing an edge coloring, there must be a red triangle or blue triangle inside it. This is a Ramsey problem. So actually, Ramsey problem is to perform 2 coloring on complete graphs to ensure the existence of complete subgraphs. In the graphs with 6 vertices, we are performing 2 coloring in K6 and could find a red K3 or blue K3.